Multimedia Signal Processing. I, Chiragan Pamwala, Vice Chair IEEE Gujarat Section and the General Chair for this particular winter school, inviting all of you for this 3 days interactive session on the advances in deep learning for multimedia signal processing. So without wasting much time, just I am sharing that what is the scope of the event and why we have initiated this particular winter school for young researchers. So actually this winter school we have planned in the month of October 2021. We have applied for the grant in the month of 2021, month of October in 2021. And at that time we have decided to touch the several aspects of deep learning, which includes the pattern recognition, signal analysis, geospatial data analysis, and quantum machine learning. These are the few topics that I am discussing here right now. And for the same, we are in need of the help of the multiple society. Hence, IEEE SPS chapter Gujarat section, IEEE Computer Society chapter Gujarat section, GRSS chapter of Gujarat section, and Gujarat section are associated together to design the flow of the program. And IEEE SCAT student branch helped us to nurture or give the shape of this particular program. For this particular program, I want to share very important thing, and this is what the dream of myself to plan something unique for this particular winter school, and that is the panel discussion for young professionals. And that we have planned is particularly that what do AI companies expect from a young engineer? Because generally young engineers or the final year students are not aware that how to prepare for the AI companies. So the special panel discussion is there on the last day for which will cover this particular aspect. Now, to make all the sessions interactive, we have planned quiz based on the topic covered by our eminent speakers. So it is not the bookish test. It is based on the topic which are covered during the session. And our quiz master will prepare the quiz on the spot. And at the end of the topic, at the end of the lecture, the quiz window will be pop up. So Professor Ketki Pathak will give the in-depth and idea about that quiz later on. Schedule is decided in this way. We have every day 3 sessions of 1 hour, and all the sessions are uniquely designed. Every day we have 1 or 2 speakers from industry and rest are from the academics, so that we have the equal flavor of both the industry and academia. As I told you, we have panel discussion slots separately. And for this panel discussion, we have 3 industry experts, Mr. Nirmal Patel, Mr. Devdutt Mukherjee, and Mr. Vijay Gabale. All these 3 are the renowned entrepreneurs who are who will help us for this entire topic. Now, related to registration data, we have stopped the registration at around 997 participants. So that is the first time we have achieved this much tremendous amount of the registration, and we have to literally stop the registration because there is a WebEx limit of maximum 1,000 participants. So out of 997 participants, around 64% students took interest for this particular program. Around 25% faculty or academicians took the interest, and 3% industry professionals also took interest. Now, age group is also diversified. We can say that around 66% young researchers, 21% are the mid-level researchers, and rest are the age group who are really established. We can say that they are established researchers took the part particularly in this program. Now, as I told you, we have around 1,000 participants and it is spreaded all over the world. So I can say that around 20% participation is there, which is outside India, and hence it is globally, it is truly international event, we can say, and we have participation almost from every part of the world. And the rest maximum participation obviously we have from the India, and in the India also we can say that Gujarat has maximum participation around 40%. Then after we have Maharashtra, Rajasthan, then Tamil Nadu. So almost diversification is there state wise also in India. We have counted the IEEE member also because it is sponsored by IEEE. So around 50% members are IEEE member and they know how to take benefit of IEEE membership. And the rest are non-IEEE member and they are willing to join IEEE based on such type of the activities. Now, out of that IEEE members, we did one analysis also that around 80%, around 20% are the SPS members out of this particular IEEE members. So there is a scope to improve that to take the IEEE SPS membership also, which is 50 cents only for student members. Now the last thing, that entire show, as I told you, that which we planned from since around the last 6 to 7 months. So we have entire team behind this program. So this is the team which are working behind this show. Uh, I gave my introduction. We have program chair Ashish Pophalia. He is basically from Computer Society side. Professor Shiv Mohan, he is basically from the GRSS chapter. Professor Mita Pamwala, she is from CSPS side. Professor Ketki Pathak, she is from SCAT SB side. And these are the organizing committee members who took the leading role. And we have the online event. So that's all from my end. Over to you, Professor Ketki.
Good evening, one and all. Thank you, Chirag sir, for the good beginning. So, good evening, one and all enthusiastic participants, eminent speaker, and organizer. I, Ketki Pathak, branch counselor of SCAT Engineering College, welcome you all for 3 days winter school on advances in deep learning for multimedia signal processing. Innovation is born of cultural excellence, and this excellence is the process when individual or nation contributes to fulfill the dreams with the calculated risk. With this famous quote by Dr. APJ Abdul Kalam, and with the blessing of Almighty, we are going to start our journey of knowledge to achieve excellence. Before we start with our first eminent speaker, there are few announcements for the code of conduction of the session. So School 2022 is 3 day long event. So here website for IEEE SPSGS will give you all the updates related to this winter school along with the WebEx link from where you can get the how to join the winter school for all 3 days. If you are having any difficulty technical side, you can also contact our technical team, Ms. Tejal Surti. All the attendees will kept mute and no video mode. Only the host can release. Session will be recorded and placed on the IEEE SPS YouTube channel. and all the presentation will be shared via WebEx, and recording will be made available to you. After end of each session, there will be a quiz related to that particular session, and the link for the quiz will be shared in the chat box, and only registered participants with the proper email ID will be able to attend the quiz. Again, there are certain rules for quiz. So a proctored quiz link will be shared in the chat box after each session. All the participants are requested to please click the link, enter your valid registered email address, and there will be unique test link will be mailed to their email address. You can open up and you can start proceeding. Only the participants with a valid registered email ID can attend the quiz. All participants have limited time to attend the quiz. Exciting prizes are awaited for top scorer for each session. Similarly, there will be a feedback link which will be also shared after each session. So we request all the participants please attend the quiz as well as provide your valuable feedback for every session. Now, with lots of zeal and enthusiasm, we welcome our first eminent speaker of session, Dr. Shikha Gupta. Welcome you, ma'am. She is a research scientist at Vehant Technology. She received her PhD degree in machine learning and computer vision from IIT Mandi. Before this, she has worked with the Samsung Research Institute, TCS Research Lab, and NIT Delhi. Her research interest lies in the scene understanding, pattern recognition, and computer vision. Her research work has been disseminated in several journals and conferences, including IEEE, Elsevier, IJST, and many more. Currently, she is actively working towards the action recognition, video summarization, person attribute recognition, and video analysis task. Dr. Shikha ma'am will share her knowledge on the title Application of Deep Learning in Video Surveillance. So we welcome you, Shikha ma'am. And now I will hand over the session to you.
Ma'am, you are muted.
Yeah, am I
Yeah,
audible now?
yeah, you are
Yeah,
audible.
I'm sharing my screen. Give me a second. So is my screen is visible?
Yes.
Yeah, yeah. Thank you, thank you. So thank you, ma'am. Thank you for the nice introduction. So hello, everyone. I will be talking about applications of deep learning in video surveillance today. And so before starting, I would like to introduce my company, that is Vehant Technologies. So Vehant is incubated in IIT Delhi in 2005. So our focus is in physical security devices, surveillance, and smart city products. And we have like two factories in India, and we are like globally, like our presence is in global market. And so I will like in next slide telling more about the products and all, like, and how we are using the deep learning techniques and all, like. So the technologies to which we are dealing is artificial intelligence in surveillance. So we are using the artificial technologies, intelligence technologies, and how like in traffic monitoring system, artificial intelligence systems are important. And yeah, so I will tell in the next slides. So our product our product portfolios include, like we have designed newer scan, that is under vehicle scanning system. So this device is also using, yeah, hello, am I audible?
Hello, hello, hello,
Yes, ma'am,
hello.
you are audible. Yes, ma'am, you are audible.
Yeah, okay, okay, fine. So newer scan is a under vehicle scanning device, and it also uses the deep learning based techniques. Another is CT scan, that is X-ray baggage scanner. So it also uses the AI machine learning based techniques to detect the to detect the different objects like knife or the like bottles, like different threat devices, right? So this X-ray baggage scanner is also installed at several places. Another is like Ocan Smart City Analytics product. So I will be explaining this in detail, like briefly in detail in the next slides. So other devices are TAFSCAN, Traffic Moon, and Enterprise Analytics. So I think I will be just introducing here. So yeah, so basically we are dealing with the as I have explained, different products. But to start with, I would say like how deep learning is coming in picture, how machine learning is coming in picture. So to like there's a to enforce for the traffic laws. So there is a module, that is Okean, one product I would say. So we can detect like if someone is violating the red light, or if someone is passing in the overspeed, or if someone is not wearing the helmet, or like triple rider. So all this is possible due to deep learning and deep learning and machine learning based techniques. So yeah, so this is like just a brief overview of traffic law enforcement, or I would say traffic monitoring system. So another is like we have developed for the COVID analytics, like if person is wearing the mask or not, or if in at a social place, or out, like outside a building or inside also, people are following the social distancing protocol or not. So this is also we have developed. Another is like hygiene video analytics. So in hygiene video analytics, things like people are washing the hand properly or not, or people are wearing the apron or the gloves in the hand at the time of doing stuff like in restaurants and all. So we have the product in this field also. Another is PPE video analytics. So at the time of working, people are wearing the helmet, jacket, gloves. So these kind of protection kits they are wearing or not. So next is more video analytics, like in the surveillance scenario. So to focus on, let's suppose if there is a restricted area and then person is entering, so that is like intrusion. Person is like not following the norms, so it's called intrusion detection. So another is crowd, like if there is some crowd is there and we want to detect the crowd number and the crowd flow. So all these things, if two persons are fighting, or if someone is doing some violence. So all these things are so there are many more. So all these things are we are able to detect with the help of deep learning. So in today's talk, I will be talking about how deep learning and machine learning techniques are important, and how they play the important role in surveillance scenario to achieve the task in real time, right? Because all the way, like earlier also traditional techniques were existing, but the main challenge was they were very slow. So just to give you brief out like overall pipeline sense. Let's suppose somewhere video is installed and we are getting the stream. So we will be applying some like detectors and classifier. So detectors will detect the object. So I will be talking about this in more detail in the next slide, so that the newcomer will also be able to understand. So as I have already explained, we are having different use cases across the industry verticals, and then we can process them, store in the database, and then there will be a GUI. On that we can can show the alerts, right? So now, yeah, so overall, like in general, what is the analytics flow chart? So we are getting, so the camera video stream, so we will be detecting the object, we will be tracking the object, and then we can apply different classification models and the classification models or the secondary models, so to say, to do the task. So I will be explaining all this in details. So first of all, this is the a street view, I would say, and then there are different objects are present. So I am talking object like car, person, animal, bag, chair. So these are different objects which may be present. So there is a wide category of objects which we can detect, or the models are trained on those. So in this we can say like bicycle is a object, car is a object, right? So if to do anything, let's suppose, so I will tell first, let's suppose we want to track a person in the surveillance view, what he is doing, and whether he is in car or he's like doing some violence or not. For the first task here is to detect that person, right? So to detect that object, and because we cannot apply any algorithm on the complete frame, it will be very time, we will not get anything, because we want to detect the activity of that person or the semantics of that person only, right? So that's why detection of object is important. We want to track that person, track that object, right? So object detection is the process of finding and classifying objects in an image. It's not like only detecting the object. If we are able to detect the car, then there will be a bounding box around car. But we have to assign a class label to it, that this object is a car, this object is a bicycle, this object is a person, right? So object detection essentially mean finding the object and classifying in its category. So three main deep learning based object detectors are there are like many more, but so in my complete presentation I will try to give brief overviews of different approaches of deep learning and how they are useful in the surveillance scenario. And yeah, so let's suppose first is the reason based convolutional neural network. So this this is the first approach that is deep learning based, and it is mean before this only traditional methods were followed, but yeah, after this like many algorithms come. So first I will give the basic of this region based convolutional neural network. So let's suppose we have an input image, and in this input image we can see like there are different objects, person is there, animal is there, right? We want to detect this object. So so this region based convolutional neural network is a multi-stage network, mean it is having multiple components which works independently. So there is a first component which will propose the regions, right? uh, so in this algorithm, there is a algorithm named as selective search, which will propose around 2000 proposals, and then CNN will be convolutional neural network will be applied on those proposed regions, so that we can get a feature vector, and then there will be a separate classifier, so to say, and then classifier will say to which category that particular region proposal belongs, right? So the standard object detection pipeline includes region proposal generator, feature extractor, and the classification. So the what disadvantage of this approach is we cannot train end to end, because there is a separate region proposal network. First we are taking an image and then computing the separate region proposals, and then passing those regions to a CNN pipeline, and then after that we are training a classifier. So classifier can be a support vector machine based or the simple neural network based, right? So due to its non capability of training end to end, it is very slow, and it is giving 5 fps on GPU. So we cannot use it in the real time, right? So to overcome these issues, several variants are developed, like by the same author. They have developed several other variants like fast RCNN and faster RCNN. In this architectures, they have tried to give the end-to-end uh, network and try to like replace this separate selective search algorithm by the deep learning based reason proposal networks, right? So the next are SSD and YOLO. So these are the single stage networks. So YOLO is you only look once. In this, one image is given to the network, and all the processing it will give in a one go. So how so I will give a brief overview how this is proceeding. Let's suppose we have a one image. So this image will be divided into S cross S grid of input. So S cross S grid, and each grid will predict the B bounding boxes, right? And every bounding box will give us the like conditional class probabilities, C conditional class probabilities. So C, why I'm saying C? So the network is originally trained for the C classes. So that I am like at the time of training, we will be knowing like what are the ground truth bounding boxes. So at the time of training, we will be able to like pass the, like back propagate to the network by taking this original bounding boxes. But here I am talking about the inference. So how the inference is happening, we are passing the image will be divided into S cross S grid, and then each grid will be giving us some bounding boxes. So after passing through the confidence threshold, we will be having few detected objects, right? So so as we can think of in the surveillance scenario, object detection is a very important stage. As if we let's suppose a surveillance camera is installed in a street, and then a few vehicles are passing, persons are passing, and some activities are going on. So the first step is to detect the objects, because before detecting everything would be like impossible kind of, right? So these detectors should be fast enough, and these detectors should detect the objects clearly. And if they are occluded and then some viewpoint is changed, so all those things should be handled by these detectors. So lots of research is going on in this direction. So now I explain the object tracking. So object detection algorithm is applied frame by frame. On the first frame, we have detected some objects. Then on the second frame, we have detected some objects, right? So let's suppose some person A is present in first frame, then in the second frame, he moved to some other place, right? So we want to track that. We want to give a particular ID, unique ID to that person, and that person should maintain that ID in the whole stream, or I would say to the time he is present, he or she is present in that view, right? So so there are lots of tracking algorithms that are like already published in the literature, that is like NV tracker and DNet, deep source. So I'm not going in detail, but yeah, I like to show uh, like what detection means. So I'm like pausing here. So this car is detected in this frame. It is assigned with like detector. What detector is doing? It is detecting this car. It is detecting this object and saying it is a car. That detector is saying it is a person. This object is a person, right? And what tracker is doing? Tracker is giving a ID, that is one here. To this car we give 18. To this person we it is 38, right? And yeah, so what tracker is essentially doing? It's trying to maintain that ID, the video processing is detecting, right? Okay. So yeah, so once we are able to track the objects, we can apply several things like let's suppose we want to count the persons, like in 1 hour, how many persons are present, how many persons are present in a particular area, right? So we don't want to count that particular person many times. So we will be tracking that person and counting it as a one only, right? Or the vehicle counting, or we want to track some object, whether that particular object is going somewhere in the restricted area or not. So we can track that person. We can detect the loitering. Let's suppose a particular track or a particular object is present for, let's suppose, 1 hour, and it is like let's suppose outside bank area. So that person should not be doing like that is a suspicious activity, I would say. So we will be detecting those alert those alerts or those objects that, so to say, in loitering case person. So we will be detecting those things using the tracking object tracking thing, right? If some object is abandoned, so we can first we will be detecting that back, and then we will be checking if some person is around or not, or something like anything. So it can be any algorithm, right? So we will be detecting the abandoned object, or there will be many vehicle analytics, like we can say, like here a vehicle is passing, so whether that particular vehicle is following the traffic norms or not, whether wearing like red light, that seat belt or not, or passing in a over speed or not. All those things we can detect by tracking, right? So yeah, so till now I have explained what it means, like what do you mean by detector, and then what we meant by tracking, and how like tracking is proceeding, right? So now I would like to explain the person attribute recognition task. So its importance, and then how much it is important in surveillance scenario, or how we can achieve these using deep learning based techniques, right? So first I will be explaining what is person attribute recognition. So in person attribute recognition task, first we are detecting a person, and then we will be predicting a group of attributes to describe the characteristics of this person, and from a predefined list. Why I'm saying the predefined attribute list? Because our model is trained for certain kind of certain list, and we will be able to detect from that particular list, like if that person is wearing what kind of shirt, or if person is what of the, like what is his gender, and what is upper body, lower body, and what is the upper body color, what is the lower body color, what is his pose, and what he's wearing in the food. So these are the attributes. So person attributes are humanly searchable semantic description. Like let's suppose somewhere some crime has happened, and we are saying we want to search a red color t-shirt, person wearing the red color t-shirt. So on all the surveillance systems we can set, if there is a person with the attribute red color t-shirt, then flag a alert, like that. So this is the importance of person attribute recognition. So now I will explain how we can achieve this using deep learning or machine learning based technique. So camera feed is coming. First, we will be applying the detector, and after detecting, we will be after detecting, we will be having this input image to pass to the classifier. Right? A classifier can be simple traditional classifier that is based on the like hawk features, or the like age-based features, or the appearance-based feature, or the CNN-based convolutional neural network-based features. So that input image will be passed to the trained CNN, and then we will be getting the labels. So why I'm talking here multi-label classifier? Because a person is not belong to a single class, it belongs to the multiple class. That's why we are saying the multi-level classifier, right? So this is very important component of a video surveillance and monitoring system, right? And it helps. So what are its applications? So as I've already explained, we can find some person, we can retrieve the data. Let's suppose there is a huge repository and I want to retrieve the images with some characteristics, so I can do that thing by writing some code and all. And so we can do tracking on the basis of person attribute also. We can re-identify the person on the basis of attribute, or we can understand the scene. If all the persons in a scene are wearing same kind of clothes, or having the same attributes, let's suppose all are standing and all, so we can understand the scene in that way. Yeah, so but there are lots of challenges to doing so. In like as I am explaining, it seems like it is very easy to detect the attributes of the person. No, we can train a convolutional neural network or the very deep network, and then we can detect. No, it is not as easy as it seems, because there are certain challenges. First challenge is multi-view, because for this image, like this image we are seeing as a single image. Let's suppose this person will like in a side view or in a back view, then it will be tough for a network to detect. So what we can do, for solving this, we can augment the data and then pass. Like there are solutions for all these challenges, but they are not like we can do the 100%, right? Another is occlusion. If a person is completely occluded, like a person is moving and then let's suppose he is hiding behind the car, so we cannot detect it, right? If we are not able to detect it, then we are not able to recognize his attributes, right? So another is like unbalanced attribute distribution. So I would say, let's suppose we are collecting a data set, we have some data set, so there will be attribute unbalanced, because there is a multi labels, like a image will belong, an image is belonging to the multiple attributes, and then we are having the data, then there will be an imbalance in the attributes. So I think so if there is some issue in that, I will resolve in the Q&A session. And in the most of the cases, surveillance images are of low resolution, and after that, if the person is standing very far away, so that particular crop of the person is very like poor quality. So detecting the like attribute from that would be a very tough task, and illumination will also play a very important role. Let's suppose it's a very sunny day or very like foggy day, so all these things, brightness and all, contrast will play an important role. And if it's a blurry image, then also it will be a challenge, right? So these are the challenges with respect to PAR. So approaches, as I have explained, we can like first apply the detector and then detect the image, and then apply, like compute the traditional features, and then train a separate classifier, that is let's suppose support vector machine or anything. Another way is like we can apply deep learning based approaches. So nowadays there are like n number of papers exist. So I have added here one I have given in the reference, that PAR, but for pedestrian attribute recognition, a survey. So that paper comes in PR, pattern recognition journal. So I'm not going in very much detail because I have to cover other topics. So yeah, this is the brief overview of the PAR. So now the next application I would be discussing, that is crowd estimation. So in the surveillance scenario, uh, there are certain situations there we have to detect the crowd. Let's suppose a camera is installed in a big hall or in a mall, and we want to detect like how many persons are inside the mall. So at the gate, let's suppose we have installed the camera and then we are counting. So crowd counting is very important in the surveillance scenario. So now I will be explaining the ways to count the crowd, count the objects in the crowd. Let's suppose we want to detect the person crowd. There are situations where we'll be counting the vehicles also, but for now I will be talking about only person. So first method would be the detection based method. So in detection based methods, we will be applying the detectors like YOLO SST or mask RCNN or faster RCNN. So using those state of the art algorithms, we will be getting the person crops, and then we can track them using suitable tracker and then count. So these methods will work when there will be like persons visible, like there is a less occlusion and we are able to detect the persons clearly. But let's suppose the crowd is like this, like in the right hand side. So like, and any detector will fail here because the person is barely visible, only faces are visible. So it will be very tough to count here, even for a person, for a human being to say like how many numbers are present here. It would be very tough, right? So the next density estimation method based methods were like proposed by the researchers, and the next is the CNN based method. So first, like density estimation based methods using the traditional features were proposed. Then the same methods were published by the CNN based methods. So I will be mostly focusing on the CNN based methods. So the first, so I am mentioning like 1-2 approaches that are existing in literature. Let's suppose first paper is deep pupil counting in extremely dense crowd. So here we can say we are not able to say like whether 490 people or 500 people, so it will be very tough. So what they are doing is they are simply passing these images, like positive images, and at the time of training they are giving the true number like 479, 490, and they are training this convolution neural network. And at the time of training, they are passing the negative samples also, the images with no objects, like no persons present. So the network will, so that the network will learn from the negative samples or the so the network will learn the semantics from the negative samples as well as the positive samples, right? So it gives it achieves certain results, but yeah, there will be several improvement after that. So another approach would be like crowd net. So so the next is like a deep convolution neural network they have proposed for the dense crowd counting. So what they are doing is essentially they are learning they are estimating the density map from the CNN, and then they are just estimating the density map, and then after that they are applying regression, some regression approach to count the number of people using the density map. So this in the above approach, they are directly computing the number from the end-to-end network. But in the next approach, what they are doing is they are estimating the density maps, right? And then applying the regression algorithm to estimate the count. So here, to just to give a one liner. So here, what CNN is doing, CNN is trying to learn the semantics of the images, like ages, I would say, and the few like how the distribution of head is going on and all. So when we will be giving the lots of images of this kind, so CNN, like convolution neural networks or the filters in it, will learn eventually the semantics of these images. So this is the result of the first approach that I have explained. So this is the actual count, 1115, and this is the estimated count using the density maps. So this is like the third approach. I'm not going in detail. I'm just showing the results here. So what they essentially they are doing is they are estimating the density map. Then they are mapping the density map to they are mapping the density map to image where they are like just marking few pixels as black, and then plotting the bounding box around that pixel, and the number of objects are the number of the that black dots, I would say. So what are the applications? So few I have mentioned at the time of starting this topic, and others are like monitoring of high traffic areas or staffing allocation. Let's suppose in a mall that camera is installed and we are saying that number of count is present, so we can staff the persons there accordingly. And if there is a sudden crowd movement, so we can track that. If like crowd clusters are present in a street, like there are several crowd clusters are present, so we can detect those also. If there is some crowd motion, so we can analyze that also, we can track that. And another is like crowd density map generation. So the important of density map generation is in case of retail, I would say, let's suppose a store is there, like in a shopping mall, or in a shopping mall in a particular store, we have installed the camera and we are trying to estimate the density map. Then in that case, what using the density map, we can say like at this particular area, lots of people are coming in particular in that particular time, like in evening, that particular product is seen by many people and all. So this that particular density map generation is also having a very good application. Yeah. So now I'm coming to the next application, that is human activity recognition. So human activity recognition is having like very wide importance in case of surveillance, because there are lots of actions which we are not able to detect using a simple classifier. Let's suppose a person is there and he is doing some activity. So what detector is doing is detector is detecting that particular instance in a static frame, right? And then tracker is tracking that. And how we are applying the secondary classifier? We are applying the secondary classifier on a particular crop. We are not considering the temporal information or the time information, right? So what human activity recognition problem says is detect the person and also recognize its action. So for recognizing the person's action, we need the information in space and time. Space mean that particular person semantics things, and the time in the time domain, what that person or what that object is particularly doing, right? So actions can be, so okay, so I forgot where it is. Yeah, action, sorry, yeah, actions can be running, tearing, riding, fighting, cleaning, throwing, snatching, etc. This video I have taken like from YouTube only, and here you can see uh, like by action, they are able to do what essentially people in essentially like at a good speed they are able to, right? So what persons are which involved picking something, carrying some object, listening to some, so those to detect. So I by this video I just want to show how people are what it means, like different activities in the surveillance scenario. Okay, sorry. So so just to give like give a brief idea how we can do this thing using the deep learning based approaches. So I'm explaining briefly. I'm explaining one paper that is two stream convolution neural network for action recognition. Uh,
Sorry to disturb,
let's,
ma'am. Your
yeah,
voice is breaking. Maybe bandwidth issue is there. So can you turn off your video?
yeah, yeah, I'm turning off. So better now.
Not yet.
Hello.
Not yet.
Okay.
Please go ahead. If something is there, I will.
So yeah, I think that mute. So I have adjusted that mic. So now it is better.
Yeah,
Hello.
yeah, it is better
Yeah,
now.
yeah. Okay, sir. Yeah, sorry. Actually, I have not checked that part. So in this, I will be explaining one action recognition module approach, that is two stream convolution neural network for action recognition in videos. So essentially, what they are trying to do is they are saying video is like composed of two parts. One is spatial and another is temporal. So I would say, let's suppose a person is dancing or a person is walking. So that person's semantic features will remain same in the like complete stream, in the complete video, but his or her action will change, right? So spatial part will in an individual frame or in the sequence of frame, spatial part will remain same, but the temporal part will change. So they have used this idea, and what they are doing is they are considering the two streams. So they are considering the two different continent. So in the first continent they are just passing a single frame, and in the next continent they are passing the sequence of frames. So that is the using the sequence of frame they are computing the optical flow, that is the like how the pixels are, like what is the flow of movement. So optical flow will capture the temporal movement of the person, and then they are like by considering these two separate network they are training this, and in the end they are fusing these two class scores. These two class scores mean from the two different network they are getting the two different scores, and then they are fusing it using the using some fusion techniques like late fusion, and uh, mean they are, and then in the end they are like training the multi-class linear SVM to detect the activity of that person. So this is very old paper, that is 2014, but after that lots of approaches came. So I have selected this particular paper just to give the like flavor as how the traditional things are moving to the deep learning things. Like here they have used the optical flow features also. They have used the CNN convolution neural networks, and then they have used like let's suppose support vector machine also, and then they are able to detect the actions. But in nowadays, like the approaches which are coming, they are directly using the like see convolution neural network, and they are training end to end, and like they are very effective, I would say. Yeah. So yeah, I'm moving forward. So action recognition. like action recognitions are very relevant in the surveillance scenario. We can detect the activities like if some person is doing violence, throwing something, hand waving mean waving hand for help, or like for the lift or anything. And in the restaurant scenarios, let's suppose some person is mopping the floor, so we can check his action whether he's doing properly or not, or he's doing the mopping or not. If someone is driving, walking, running, like carrying something or snatching something, so chain snatching and all those things, activity in the surveillance scenario, we can detect using the action recognition task. So there are like very like good amount of challenges here, I would say. So first, dependency on the detector and the tracker. Why I'm saying this? Let's suppose surveillance camera is installed in some street, and then we want to detect these actions. But if detector is not able to detect the object, so what action recognition model will do, right? So detector should be very good, and in the certain scenarios, it should be able to detect the object, and tracker should able to track. Let's suppose a person is doing some activity, dancing or throwing something, so tracker should able to detect in the consecutive frame that person is with ID 1 only, right? So if that person, that tracker is able to track that particular person, then action recognition model will able to like consider those temporal movement and then give the right result, right? So there is a good dependency on detector and tracker. And tracking the long term temporal interaction is also very difficult. One is like tracking the particular object, another is modeling that temporal interaction, what that person is doing. So so network should able to train in such way that it can detect the temporal interactions also, right? So it, and also there is one more challenge here, I would say. Let's suppose a girl is just matlab, taking the tea, so or like anyone is eating something, so I would say there is nothing like only a single person actions. There are things like interaction with respect to other objects also. So we need to model the interaction of different actions together. If some person is giving something, another person is taking something. So our models, deep learning based models, should be as much smart so that they can detect these actions very clearly. Also our model should not be very slow by in the process of all doing all these things. It should not be slow, because we want to do all these things in the real time, like real time scenario, right? So there will be background clutter, partial occlusion, change in scale as the person is moving. So his like that object crop will change its scale and all. So viewpoint point will be changing, lighting will be changing. So all those things should be like that model should be cater all those things, right? So in the action recognition field, people are mostly using the 3D convolution neural networks. So in the like 2D convolution network, the filters are applied on the image, or I would say in the spatial domain only, like in a XY domain, I would say. But in the 3D CNNs, that particular filters are moving in the temporal domain also. So 3D CNNs are giving higher accuracy with respect to 2D CNNs, but they are taking lots of time in the training also, and deployment to the edge devices is very tough. So because inference is like at the time of inferencing or the testing, it is taking few seconds to give the answer. Yeah, so now I would say like there are many more such applications that can be caters using deep learning based approaches. Let's suppose abundant object detection if some object is there. So here I would tell the challenge in the abundant object detection. Let's suppose some person left the bag and our detector is able to detect only bag. So then we will be able to detect that bag is abandoned. But let's suppose if some another object that is not present in our detector list, like for a detector there will be a certain list of object that the particular detector will be detecting, but that object is something else. else, some in some random shape and all. So at the time, detecting that object as abandoned would be very tough task, right? Another is object removal. Let's suppose at some places an particular object is placed, and we want to uh, observe that object whether it is removed or not. Means someone is stealing it or not. So so we need to generate an alert of if a particular object is removed. So all these things these kind of things also require the deep learning based approaches. It's not just only convolutional neural network, I would say, like take a lots of data and then train. No, no, it's all about approach also. What approach you are following, what loss function you are applying, and kind of data is present, how you we are tweaking, and we are like solving the maths behind that and all. So that will also plays an important role. Another is another analytics or another dimension, I would say, is personal protective equipment safety analytics. So to detect, let's suppose in a particular factory, surveillance camera is installed, and we want to check if person is wearing the jackets, in the harness, and all these things, all those equipments and all, or not. So detecting those persons and then applying the secondary classifier and then check. So that will also be another application in case of surveillance. Another is like detailed video analytics. So as I have told in my presentation, like if in a store camera is installed, so we can track like at what time many persons are present, and at what time there were no person, or to which particular category people are visiting more and all. So this will help in improving the customer behavior, or like, so we can organize our stores in that manner. So we can, using deep learning, we can like detect the customer behavior also in the similar way. And another main vast dimension would be a real world anomaly detection. So this is like a very important field in the surveillance scenario. Let's suppose some anomaly is about to happen or happened, so we want to generate an alert. Anomaly can be, let's suppose a particular road is a one way, and some vehicle is coming in the wrong direction, so that will be a one kind of anomaly. And if, let's suppose, some person is collapsed, so that is anomalous behavior. Or some person is waving hand, so that is one another kind of anomaly behavior. So anomaly can be like of many kind. So to train the network with respect to anomaly would be very tough. So research is going on in this direction. Another main dimension I would like to touch upon is synopsis generation or the video summarization task. So in this in the case of surveillance, there is like 24/7 feed is coming, but the operators or the persons are, they are not having time to check the complete video feed, like 24/7 feed. So we want to like design such algorithms, we have to design such algorithms so those can do the synopsis, like those can create the synopsis of 24/7 videos on the basis of attributes and analytics, right? So I think these are the different analytics or the dimensions which are present, or like research is going on in this direction. So yeah, I am wrapping up here. Now please ask the questions if any you have. Hello. Yeah, so I'm checking the chat. There are a few questions. How to identify the activity is normal or abnormal? If person running can be normal or abnormal. How to identify the activity is normal or abnormal if person is running? Yeah, if a person is running, then that particular activity can be normal also. But we need to define like area. If we are seeing this thing in a park or the jogging track, so it would be normal. If, let's suppose, on a road or on a particular place, we are defining like a particular person should not be running. So then in that scenario, we will be saying that is a normal behavior. So another question is, so now my voice is clear because I have seen many comments like voice is not clear.
Yeah, still there is
Your
an
voice
issue.
is clear.
Yeah. So I'm reading another comment. If a person goes out of the video frame and after some time returns in the frame, will the person be identified with the same ID as before, or will it get new ID detector? So first of all, the detector will just only detect the objects. Tracker will give the ID to that particular object. Yeah. So it will totally depend on the history we are maintaining for a particular detector. So whether we are maintaining the long-term history or the short-term history. So it's all about the features we are computing. Let's suppose we have detected a particular person, detected a particular object, and it goes away, and then it comes. Let's suppose after like 5 minutes. That once he is entering in the view again, so we will be computing its semantic features and then matching with respect to the stored object. And if it is matching, then it will definitely get a new ID. But if our algorithm is devised like that, objects are not stored for a long time, so then it would be very tough. So another question is, for real-time action detection in crowded environment, algorithmic complexity plays important role. How the use of deep models can be justified? Yeah. So in the action detection task, people are still struggling with respect to getting the good FPS and all, I would say. So so deep learning models. So deep learning models are just we are saying like there's lots of data and then we are training, but all aspects will also play important role. What framework we are using, and what detector we are using, and how. So if you want very accurate or a bit of less accurate framework and all. So I think that answered my question. What would be the possible risk due to black box or deep learning model in the context of video surveillance? So I would not say like black box nature of deep learning models. Let's suppose I have trained a model to detect a person is wearing a mask or not. So in that case, there will be first a detector that will be detecting the face, and then there will be a secondary model. So whether mask. So in that case, there is like we have trained a model with respect to that kind of data only, with respect to face mask data, right? So we can't say like black box nature. So we have to first analyze the scenario for analyze the problem to which we want to train. So we want to train for crowd or the action or the person attribute, and then there will be few chances here we will get an unpredictable behavior, answer. But if we will be analyzing through, let's suppose, GradCam, what network is essentially learning, user attention maps, and tweaking the model and giving some weightage to the particular data or image, then that would be helpful. So next question is actually going to be the best for medical image segmentation. So sorry, I'm not worked in it domain, so I can search and Google has started the visual positioning system. So I think I don't have much idea in this domain, so I will skip that part. If two objects having the same shape or texture, then how to detect them? Example, mobile and TV remote. Okay, so network would be confused in that case, because if two particular remotes are exactly same to us for a human being, then the network would also be able to confuse. But in the training data, if we are applying good amount of data mobile and remote, then there are certain as the data will be more, let's suppose 1,000 training images we are giving, then in that case the network would be able to learn by some semantics, because mobile and remotes are not same. As we all know, there are different features, there are lots of time, but in mobile there is a scene. So all those features definitely network would be able to learn. So how is real-time processing handled in video surveillance? And latency, yeah, there are lots of latency issue and we also faced. So but we need to sometimes compromise with accuracy and Sometime we have to use like like less class classification model, or with the less weight. We sometimes, like in general, also literature, in literature also few networks are exist with the pruned weights, like pruned weights. If let's suppose VGG network is there, and a few weights are randomly pruned, so then network, then that model is lightweight, and then people are using those, right? So which detector you are using? So I can't tell that question, like which detector we are using in our device. So the next question is, in video frame, if there are many persons, which deep learning models can be used to predict action each person separately and in parallel real-time fashion, as data set present only for single person, single repeated activity? Okay, so I would like to answer this. Let's suppose we are getting a video stream and then many objects are present. So these action recognition models are not applied over the complete frame. They are applied over the detected objects. So detected objects are so give me a second. Okay, so let's suppose this is the a particular image. So detected object is, let's suppose, car. So the action recognition model will not be applied over the complete frame. It will be applied over this car detected object only, and like as the car will move, and in the consecutive frames we will get the bounding box, like the crop region, and then the action recognition model will work on it. So by that I think I answered your question. Which detection you are using for walking and suddenly stop conditions? So in CCN, we can, I think, cater this by considering the by tracking by certain tracker. Let's suppose if a particular person is tracked by a tracker, and then that particular object is stopped, and then we using tracker will give the position of the particular object in a frame also, right? So it's not only CNN. So CNN will just learn the features. So after that also we need to write certain algorithms and write some logics to solve our task. So detector will detect the person, tracker will detect that. But if we want to check a person particular object is suddenly stopped or not, then we have to write a certain algorithm in our way by using the, we will be using that object data. How to combine micro actions like walking followed by running into suspicious high level activities. So I think by using the like tracking will give us the all the details, and after that we have to write our algorithm. Okay, what is the minimum size of object in term of difficult? That I think this is a not the relevant question. Uh, yeah, so lots of queries with respect to my voice, and so sorry, very sorry for that. Yeah, if there are further questions, then please ask, or I will give my email ID. Then I would be happy to answer. Yeah, thank you.
Thank you, Sikha ma'am. It's really wonderful session, and really interesting session about object detection and identification and various applications learned by participants. Uh, so, on behalf of entire team, I want to share the e-memento with you. So, just allow me to share the e-memento on behalf of the team of Winter School. Yeah, Tejal ma'am is sharing. Thank you very much. This is e-memento as it is virtual mode, so we have to deal with this one. And thank you once again for giving your valuable time. Yeah, obviously we will share this e-memento through mail in the due course of time. Thanks once again.
Thank you. Thanks a lot. Yeah, it's
And
nice explaining me.
yeah,
Thank
and
you.
I am requesting all the participants to share the feedback form for this particular session, and the quiz link is also given in the chat window. So kindly attend the quiz, and the quiz will be open for limited time period. So just you can start attending the quiz.
Sir, excuse me.
Yes, Tejal ma'am.
Can we have a group photo with ma'am?
Yeah, we can have group photo. I think Goro sir is also there, so we can make Goro sir also host. And all the participants can turn on their video also. So Tejal ma'am, you have to click.
Ha, sir. Just a minute.
Okay.
I think Gaurav sir's video is not. Yeah, sir is there. Thank you, everyone.
Thank you. And quiz link is also already there. Yeah, link for test day one, session one is there. So it is the testmost.com. So you have to click on this link. You have to enter your registered mail ID through which you entered the particular session. Else you are not able to take part for this quiz. And once you will register through your registered mail ID, you will receive the quiz link on your registered mail ID. And you cannot change the tab. So that is the system we have established for this particular quiz. And you cannot go back to attend the previous question. And there is no negative marking. So meanwhile, I want to welcome great speaker and one of my guru, Goro Sharma sir, for the talk. Welcome, sir, for this talk. And you have early morning over there.
Yes.
And you have given the time to us. So let's introduce Goro sir. Gaurav Sharma sir is a professor in the Department of Electrical and Computer Science and Biostatistics and Computational Biology. And he is a distinguished researcher in a Center of Excellence in Data Science at the Gurgian Institute of Data Science at the University of Rochester. He received the PhD degree in Electrical and Computer Engineering from North Carolina State University